Hello friends, welcome to our channel Knowledge Amplifier. So in our previous video, we already discussed this topic that Kafka topic partitions drive parallelism in Faust application, right? If you are not aware of this particular concept, I will request you to go through my previous video. The link I'll be providing in the description box or in the comment section because that concept will surely help us to understand today's topic in a much better way. So topic partition parallelism in case of Faust application have a very important impact while working with Kafka tables. Let's try to understand that if you are using Kafka tables in Faust application and your topic is basically partitioned, then what might happen, and there is a possibility of long computation and how to ignore that. All these topics we are going to discuss today in this particular video. So let's start our discussion with a particular topic. Here suppose this is our topic and that topic is having two partitions. Okay, one partition is P0, one partition is P1, and this is our input topic. Input topic meaning that the producer is publishing the data in near real time to this topic. And maybe for example, consider in this case the input data are transaction data, okay, for a particular bank. With that transaction JSON data, the user ID is coming. Then maybe the next key value pair can be amount, how much withdraw of amount happened, okay. Then the next can be from which country the transaction happened, right? So these kind of transaction informations our producer is publishing in the input topic. And in the producer, the code to partition the data is written such way that if the user ID is even, it will go to P0 partition, and if the user ID is odd, then it will go to P1 partition, okay. So all the even user ID going to P0 partition and all the odd user ID going to P1 partition. Suppose that is how the partitional logic is written within the producer. And let's consider there are 6 transactions for user ID 1, 2, 3, 4, 5 and 6. Okay. Maybe the first user with ID 1 has done transaction from India. The second one has done from USA. The third user has done from maybe Nepal. The next fourth one maybe has done from India. Then this fifth one from USA. And then sixth one, for example, let's consider from Nepal. Okay, right? So these are the different countries from where these user IDs have done transaction. Now, when the producer will publish the data based on this particular partitioning logic, then how the data will be distributed? It is like in P0, all the even user IDs will be coming. So in our case 2, 4, 6, these user IDs will be coming. And in our P1 partition, because all the odd user IDs are going there, so 1, 3, 5, these 3 odd user IDs will be going here, right? Now suppose the business requirement is country wise how many total transaction done, that we have to compute, okay? So it is same like our word count problem, that in our Kafka topic the sentences are coming and which word has appeared how many times in our input stream, that we want to compute based on word count. We want to aggregate the data and publish it. So that same concept we can apply in this case. We have to use Kafka table. Maybe we are running a Faust application which is consuming from this particular topic, and then suppose there are 2 worker instance running for the Faust application, okay. So here we are having our worker 1 and here we are having our worker 2. So here, because we are having 2 partitions in this topic, so maximum 2 worker instance for the same Faust application we can start, so that parallel processing will happen. One worker instance will start consuming the data from this particular topic, another worker instance will start consuming the data from another topic P1. Like that, suppose that is the situation. How the code will look like? It is very simple, which we already discussed in our previous video while discussing word count problem, kind of that only. So here we are importing Faust application. Then here we are creating the Faust app, right? We are providing the broker URL where our Kafka is running, and topic partitions 3. So here topic partition, you have to give that particular value which your topic is having how many partition. Like for example, in this particular context, in this topic we are having 2 partition, right? So what we have to do? Topic partition, we have to write 2 in this case, like that. And then what we are doing here? We are creating a complex data type, withdrawals data. So if you recall, our input data is having this kind of key value pair: user ID, amount, country. So user ID can be integer, country can be string, and amount can be integer. That first record I am creating serialization JSON. Then here we are subscribing to our input topic. Suppose the topic name is transactions underscore topic 1, and in the value type we are mentioning this particular complex data is coming. Now here we are creating a table for our first application, and then here we started our agent. Agent is nothing but acting like processor for our input stream. Here this function will be executed, dev processor. Using for loop, we are basically consuming the data from input stream. We are printing the message, that is totally optional. And then for any particular country, whenever we are getting a transaction, for that country, the value part we are increasing by 1. So as per this particular logic, what will happen at the end of the day? That if we see for a particular country, what is the value? That will indicate total number of transactions done from that country, right? And then that particular table we are printing in the terminal or console in the logs. As simple as that. So suppose this first application has 2 worker instance running. Okay, because in our this particular case we are having 2 partitions. So for parallelism we can launch 2 worker instance, and suppose that worker instances are aggregating the data based on country, that in what country how many transactions happened. Okay, now the worker 1 is consuming from P0 partition, worker 2 is consuming from P1 partition. Now based on distribution of data, it got 2, 4, 6, these 3 user ID. If you see 2 is from USA, so worker 1 will print the result set like this, that is here country name and then here count, right? Now here if you see country is USA, so for worker 1 in from USA, how many transactions happened? 2 is from USA, then 4 is from India, 6 is from Nepal. Okay, so USA, India, Nepal, USA 1, India 1, Nepal 1. This our worker 1 will be printing after aggregating the dataset over our P0 partition. What about worker 2? The transaction 1 is done from India, so India 1. Then here 3 is from Nepal, so here also Nepal 1, and then here 5 is done from USA, so USA 1. So worker 2 will print this particular data after aggregating based on country. Now you see the problem. Both result what our workers are printing, they are wrong, because actually in our input stream, if we are doing grouping based on country, then what result we should get? Based on India, the total number of transactions are 2. From USA, total number of transactions are 2. From Nepal, total number of transactions are 2. This is actual count, but because the data is getting distributed among different partitions, not based on country, but rather they are getting distributed based on user ID. But after distribution based on user ID, we are doing group by on country, so we are getting wrong result. Because in case of worker 1, if you consider, another transaction from India is available in partition 1, but the partition 1, the worker 1 cannot access. It only accessing the data from partition 0. And that's why it is showing that from India only 1 transaction happened. But actually another transaction from India is available in worker 2, that is in partition 1. So the actual outcome should be 2, right? So I hope you are getting it, that in case of first application, if in your input topic the data is coming based on a particular property of your message, and then within the first application you are aggregating the data based on some other property of your messages, then you will get wrong result, right? So this particular code will give us wrong accumulation information, that country wise how many transactions happened, that information will be showing wrong in this kind of code. So we need a solution, because this kind of situation might often appear, that the data is getting distributed among partitions based on a particular property, and then we need aggregation based on a different property. So what we will do in this case, we need to repartition the data before aggregation. Okay, so what we are saying, that you can do aggregation and split the data in the topic based on user ID, but in the middle there should be an intermediate layer. How the layer will look like, let me show you. Let me just erase all this. So what we have to do is, here in different partitions the data is getting distributed based on user ID, that is fine. In the middle we need to write a block where all the data will be coming, and then the data will be distributed based on that particular property of the message on which we are trying to aggregate in our Faust application in the Faust tables. Okay, like for example, here ultimately we want to aggregate based on country. So in the middle, we should be having a layer where country-wise grouping will happen. That is, all the transaction related to a particular country should reach to one particular partition. Maybe for example, we are having 2 partitions in this layer also, and all the India related transactions are coming in this partition only. Maybe for example 1 and then 4. So I will write here 1, 4 from India it came, and then here maybe from USA whatever transaction happening that is accumulating in this particular one. So that is basically user ID 2, and USA another one is user ID 5, and then from Nepal whatever transaction happening maybe that is also coming in this particular partition only, that is 3, another from Nepal is 6. Okay, so what happened in the middle layer? We basically partitioned the data based on that property on which we want to do aggregation. Now suppose there are 2 worker instances for the same Faust application running. This worker instance will consume the data from here, this worker instance will consume the data from here. Now when the aggregation or the same logic will be implemented, what will happen? That because all the India related transaction is available in this particular partition only, so it will be giving correct result. That is, for India number of transaction is 2, for Nepal the number of transaction is 2, and from this partition when another worker instance is consuming for the same Faust application, it will give from USA number of transaction is 2. Okay, so all we have to do in the middle, repartitioning of data based on that particular entity on which we want to do group by, that we need to implement, so that for that particular property whatever data is there, that will be reaching to one same place from that particular partition our worker will consume, instead of consuming from the actual partition. Okay, so the intermediate topic and intermediate partitions, how we can create in Faust? It is very simple. Just in this for loop, let me just erase here. So this particular for loop, if you see what it is doing, it is consuming the data from stream directly. So when we are writing this code, that means the worker is directly consuming from our original partition, but we want to add the middle layer and we want to make sure the distribution of data is happening based on that particular entity on which we want to do group by, right? So what we will do, we need to write stream dot group underscore by, and then here we need to write country. Okay, because in the computation layer based on country we are doing aggregation. So first we are redistributing our data, repartitioning our data based on country. That is the important step. So I hope you understood that when your input topic is having multiple partitions and for parallelism purpose you are running multiple instances for your same Faust application, then to avoid miscalculation you need to use the group by to make sure distribution of data is happening based on that particular entity on which we are trying to aggregate the data, so that it will give us the correct result. Otherwise, for that same property might be in some other partition, some data will be sitting which our worker instances will not able to capture, so it will miss something if we are not adding that middle layer using group by, right? So let's try to understand this particular phenomenon with programming now. So what I will do here now, I will go to my notepad and I will start Zookeeper in PyCharm in a console, right? And then here I will start my Kafka broker. And then here what I will do, I will create a topic with 3 partitions. Okay, transaction topic 1, that one let me create. Okay, the topic got created successfully, fine. Now here I am writing my producer code. It is a very simple code. If you see here, we are doing all the necessary imports, and then here custom partitioner we are implementing. Like if you see the discussion, I told you, right, that might be the partitioning logic is all the even user ID will go to one partition, all the odd user ID will go to another partition, like that. So in this kind of case, we need to implement custom partitioner. So same thing we are doing here. What we have implemented, that the key we are consuming and then we are dividing by total number of partition. So in our this particular topic, we have total partition as 3. So always we will divide our key by 3 and then whatever remainder we will be having, based on that we will distribute our data among three partitions, either partition 0 or partition 1 or partition 2. So like for example, suppose the key is 1, that is user ID is 1, then 1 mod 3, we will be getting 1, so that data will be going to partition 1. Suppose the user ID is 2, then in that case 2 mod 3, we will be getting 2 only, so that particular user ID related transaction will go to partition 2. Suppose the user ID is 6, so 6 mod 3, we will be getting 0 as remainder, so in that case the data related to user ID 6 will be going to partition 0. Like that, the custom partitioner is working. Here we have created our producer, we are giving the topic name. Now from which country transaction is happening, for that here we have created a list. Each time to generate a dummy transaction, we will pick up some country randomly out of this dataset. Okay, 10 transaction we are publishing, so E will vary from 0 to 9. That we are taking as user ID. The country name we are picking randomly from here, and then amount only 1 rupee or $1 only transaction happening, let us consider, because here we are not interested that how much money transaction happened. We are now considering that based on country how many transaction happened. Okay, so if from India, suppose someone is taking 1000 rupees withdrawal or someone is doing 50 rupees withdrawal, that is same in this kind of aggregation, right? So for generating this dummy data, I just kept amount as 1, very simple, but in actual scenario it can be different, that is fine. Okay, so here what I will do, I will copy the producer code, and then here in producer.py file I will paste that code. Okay, right, now here what I will do, if you see, this is our consumer code. In the consumer, we are creating the application, we are defining the complex data type for our transaction data, we are subscribing to the transaction topic 1, where our producer is basically publishing the data, and then here we are creating a table pointing to this particular application. Okay, and point to be noted, while creating the application, here we have configured topic partitions equal to 3. This is very important for your application. If you are defining like this way, then all the intermediate topics whatever will be created by the first application, those will be having same number of partition as of our application. So because our actual input topic, that is transaction topic 1, it is having 3 partition, so for our application and all the intermediate topic also we kept the same number. Okay, so this table also in the backend it will be having a changelog topic. That changelog topic will be also having 3 partition, and then here we are increasing the count by 1 for that particular country for which transaction happened, and we are printing the table. As simple as that. Now here what I will do, I will copy the consumer code, I will go to main.py, I will paste the code. Okay, right, I hope up to this it is very simple. Now the next step is we need to start multiple workers for our same first application. So for that what I will do, I will start one instance using this code which I already discussed in my previous video, and the another one, because I am starting in same machine, so I need to change the port. Okay, so here I will open a new terminal and I will paste this particular code. Okay, so here if you see that it will join that particular consumer group and it is also started. Now what I will do, I will start my producer code. Okay, so here see, it published 10 transactions randomly, and point to be noted, from Bhutan how many transactions happened? 1, 2, 3. Okay, from Bhutan 3 transaction. Then from USA we are having 1, 2, 3, 4, 5 transactions from USA. From Nepal how many we are having? From Nepal we are having 1, 2, 2. Okay, so total 10 transactions, out of which Bhutan 3, USA 5, Nepal 2. Now let's see our first tables. Okay, so if you see the first table, what finally we are getting for the first worker, that is USA 3, Bhutan 2, Nepal 1. So see, actually from USA 5 transaction happened, but here this particular worker instance is accumulating the data from one partition only, and it is saying that from USA only 3 transaction happened. Now suppose the business team is looking this particular table, they will get wrong information, because in the another worker instance the other 2 transactions for USA went. Okay, what is the reason behind this? Already I discussed in the theory section, right? Now we need to avoid this particular problem by adding a group by clause. So we will do that. So what I will do, I will close this particular first application worker instance, and same I will do for this one also. Okay, and then here let me go to the correct case. Okay, we understood the wrong case, now we will see the correct case. So to demonstrate the correct case, I am creating another transaction topic so that the earlier data, whatever is available in transaction topic 1, will not confuse us to understand the result. So for that I am creating a fresh topic with transaction topic 2, and then here I will paste the code, let it get created. Producer code is same, just we are changing the topic name, that's all. Okay, I will copy this and then here I will paste that in the producer section. Okay, it is pasted, and like already I discussed that if you see the logs, then I told you, right, that whenever we are mentioning in this application that topic partition should be 3, the first will create all the intermediate topics like changelog for our table, that also will be having 3 partition. Let me show you that so that you will be having a clear idea. See, 3 changelog topics got created for the same table because in our application we defined 3 partitions only. Okay, right? So that I hope you got it. Producer code is updated. Now in the consumer code, what we are doing, what update we have implemented, let's see. That is, application code is same, just we change the application name little bit. Maybe here let me give 1 to something. Okay, for this particular application we are creating this particular table. Okay, and then here also we mentioned topic partitions equal to 3 in the application, and here is the change. Earlier we were directly consuming from stream, but now we are consuming after repartitioning the data or regrouping the data based on country. So withdrawals data is our complex type. In that, this particular property is present, which is country. On that we are regrouping our data, and from that intermediate topic we are consuming and doing aggregation based on country, so that same country related transaction will be available in same partition. As simple as that. So here what I will do, I will copy this particular consumer code, I will go to main file and I will paste this, and now here I will again start the 2 worker for our same first application. So here it is started, and let me start in another terminal. So here this also started. Okay, right? Now let it start. What I will do, I will start my producer. Okay, and this time we should see correct count based on country when we are grouping the data, because now same country related information are available in same partition. So here you see how many transactions happened from USA. 1, 2, 3, 4, 5. From USA again 5 transactions. From Bhutan 1, 2. From Bhutan 2 transaction. From Nepal 1, 2. From Nepal 2 transaction, and from India we are having 1. Okay, so from Bhutan to USA 5, Nepal to India 1. That is basically the distribution of transaction. Now let's see the terminal. So in our first worker instance, only USA and Bhutan related transaction came, and see it is giving correct count. USA 5 transaction happened and Bhutan 2. Okay, let's go to another worker instance. See here from Nepal 2 transaction happened and from India 1 transaction happened. And the reason is very simple. In the middle here, that intermediate topic got created where the data is getting distributed based on country. Even in the logs, you can see that particular intermediate topic also. Let me show you that. So if you see, 3 repartition topic got created. So regrouping based on country, right? So here see the name at the end, country hyphen repartition hyphen 0, country hyphen repartition hyphen 1, country hyphen repartition hyphen 2. Like that it is happening. That means it is indicating it is distributing its data or repartitioning its data based on country in the intermediate layer. Okay, so that way multiple worker instance also, if you are running for increasing the parallelism for your same first application, then also the problem we will not face what we were facing earlier. So the group by plays a very vital role in case of first application, especially if you are working with tables, right? Just remember this particular concept, because this concept we are going to encounter in our upcoming videos also. Whenever we will try to implement real project and in industry level project, then this concept is very helpful. I hope you understood this. All the codes I'll be providing in the description box or in the comment section. You can go through that, try to play with it, try to understand each and individual line. If you have any doubt, you can ask in the comment section. I will try to reply ASAP. So this is all for this video. If you find this video helpful, then please like, share and comment, subscribe our channel if you have not subscribed till now, and don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.